factorization by difference of two squares. Let us take our time to understand the meaning of difference of two squares. From mathematics or in mathematics, the word difference means subtraction. So when you say difference of two numbers, it means the subtraction of two numbers. So let's say the difference of A and B will become A minus B. Now, let's take the next word, which is a square. A square is any number raised to the power of 2. For example, A power 2 is a square called A squared. So we will consider this entire term in mathematics as a square. Let's take another square. Let's consider a square like M squared, meaning M raised to the power 2. So this particular term is also a square. There are two different squares over here, A squared and M squared. They are the two squares. So if you want to difference the two squares, it will be the subtraction of these two squares. So A squared minus M squared now qualifies to be difference of two squares. Why? There is a difference in the form of subtraction sign, and there are two squares which are A squared and M squared. So generally, this is the appearance of difference of two squares in mathematics. Now that we have understood the general form of difference of two squares and how you can be able to identify difference of two squares, let us now take a look at some extra examples of difference of two squares. Now I have x squared minus y squared. This is a typical example of difference of two squares. There are two squares which are x squared and y squared, and there is a subtraction sign which represents difference. So we can conclude that this expression is difference of two squares. Now I want to draw some clear-cut difference between difference of two squares and the perfect square. Mostly students confuse x minus y all squared to be x squared minus y squared, which is absolutely wrong. Why am I saying that? This is a perfect square. You cannot convert this into x squared minus y squared. It will be wrong. But rather, instead of you treating this perfect square as difference of two squares, which is wrong, you need to clear the squares. It is this expression, which is x minus y, multiplying the same x minus y. In a nutshell, it is this x minus y times itself. Are we getting the whole thing? So x minus y times itself, which becomes x minus y, into bracket another x minus y. So this is a perfect square, whilst this is difference of two squares. So we should not confuse difference of two squares with the perfect square. Now at this stage, let us go ahead and see how to factorize difference of two squares. Factorize x squared minus y squared. As usual, we have two squares with a subtraction sign, which makes it difference of two squares. Then let's factorize it. We draw two brackets. We get our minus and our plus sign. So x, y, x minus y, then x plus y. As usual, you can still interchange the signs where plus or the positive starts and then the subtraction goes to the other bracket. So this becomes the final answer of x squared minus y squared. Question number 3 reads, factorize r squared minus 3 squared. Checking from the question, you realize that r squared is a square and 3 squared is also a square. So we have two squares with a subtraction sign representing the difference. So difference of two squares. For factorizing or to factorize difference of two squares, we need to draw two brackets. Then we need to get the first number r subtracted from the second number 3. So r minus 3. Then we do the addition of the two numbers, r plus 3. So this becomes the final answer. Question number 4. It says factorize v squared minus 25. Now in this part of difference of two squares, there's a simple trick. You see, v squared is a square. 25 is a real number or a whole number. For you to be able to get the difference of two squares itself, we need to convert 25 into a square. Now 25 can be 5 raised to the power 2, since 25 is a perfect square. So this can be written as v squared minus 5 squared, where 5 squared represents 25. So now we have arrived at 2 squares being subtracted. That is difference of 2 squares. Then we finalize our answer by drawing 2 brackets where we have the v minus 5. You subtract the numbers, then you add the same numbers, v plus 5, making a difference of 2 squares. Now, don't forget that the final answer comes this way to show that we are done. So v minus 5, v plus 5 is the answer. Let's take question number 6, which says factorize a squared b squared minus x squared y squared. In this question, it looks as if the squares are many, but they can still be represented in 2 different squares. Let's check a squared b squared, the first term. We can write it in different form, which is ab all squared. That is to say a times b all squared. Since the 2 squares are multiplying, it is easier in the indices property to represent ab all squared with a single square outside the bracket. The same thing applies to the second term, which is x squared y squared. We can still represent it as xy all squared. Now that we have the 2 squares, the first square is ab squared and the second square is xy squared. We draw 2 brackets. Then we take the first number ab, then we subtract it from xy. We take the same number ab, this time around add it to xy. So this will become our final answer for the factorization. We are making it more difficult along the line. This time around, I can see 4 as a perfect square multiplied by s squared. So let's change 4 into 2 squared, since 4 is a perfect square. So it becomes 2 squared s squared. So 4 has been converted into 2 squared. Minus 9 can also be converted into 3 squared. So 3 squared r squared. Now, we will still have to get our 2 squares with the subtraction sign. So 2 squared s squared can be written as 2s all squared. Then minus 3r all squared, representing 3 squared r squared. Now that we have 2 squares with a subtraction sign, we can talk about difference of 2 squares. Let's now continue by drawing 2 brackets. Then we have the first square, which is 2s, minus the second square, which is 3r. Then we have the same thing with the addition, so 2s plus 3r. This will therefore become the final answer for the question 4s squared minus 9r squared. Question number 8 says factorize 25s squared t squared minus 1. This is still an example of difference of 2 squares. Let's just convert it into a more visible question on the difference of 2 squares. So 25 is a perfect square, so it will become 5 squared. Then we have s squared with a t squared minus 1 is also a perfect square, which is still 1 squared. That is the meaning. Now let's combine this into a single square, which is to say bracket of 5st with a square out minus 1 square. So now the 2 squares are visible. The 2 squares are visible. So 5st squared as the first square and then 1 squared as the second square. Let's draw 2 brackets to finalize the answer. So we have in the first bracket, we have this minus this. That is 5st minus 1 without their squares. And the same thing added, 5st plus 1. So this becomes the final answer for 25s squared t squared minus 1. Question 9 says factorize x squared minus 1. This question looks very simple. Let's see how we do it. Let's change 1 into a square. So x squared minus 1 squared. It may not be important to bring the 1 square, but for those watching to be very sure that 1 is a square and to be sure that we have difference of 2 squares, that is why I've brought a square. But when you are solving, you can choose to ignore the 1 squared and go straight to open 2 brackets and then get x minus 1, x plus 1 as your final answer. The same thing goes with if the 1 starts, is the same thing. It becomes 1 squared minus x squared, still difference of 2 squares. So please take note of that. Question number 10 is a little bit difficult than the rest of the questions. It says factorize 9a squared minus into bracket a plus 1 all squared. You have to take your time. I want to use the difference of 2 squares approach, which is a little bit simple for me. Now, checking from 9, 9 is a perfect square. A is also a square. So the two of them can represent our first square. Then I have a plus 1 in the bracket as a single term, all squared. Are we getting it? Now let's continue by converting 9 into 3 squared. Then a becomes a squared minus a plus 1 all squared. Still converting, I can put the two of them into one bracket to represent a single square, which is into bracket 3a all squared, representing a single square, minus a plus 1 all squared. So from the board, you can see that 3a squared becomes the first square, and then a plus 1 all squared becomes the second square. Don't get confused with the a plus 1 all squared. Just consider it as a single square, which is called a plus 1. If you treat it as a single square, you'll be able to know that this is our first square and this is our second square. So I'm going to open two brackets. Still the same method I use in finalizing factorization by difference of two squares. So in the final stage, I'll take the first square, which is 3a. Then I will subtract it from the second square. Remember, the second square is a plus 1 in the bracket. So it becomes a plus 1 in the bracket. I'll do the same thing here, but this time around, I will add the two. The first square is 3a, so 3a. Then I'll add it to the second square, which is a plus 1. Still in the bracket, for safety's sake, a plus 1 in the bracket. Now, these are the two brackets I have. Now, don't forget, we have like terms within the bracket. So if you leave your answer this way, you may not be wrong, but you can simplify further. So let's just go further. So then it becomes 3a. The minus goes into the bracket to expand, making it minus a, then minus 1 in the first bracket, minus 1 in the first bracket. Then we have the second bracket becoming 3a plus, this is not minus, so we can still take off the bracket with a 1. 1 times a becomes a. Then 1 times 1. Then 1 here times 1 becomes 1. So plus 1. Now let's simplify those in the bracket. We have 3a minus a as a like term. And 3a minus a is 2a. So bracket 2a. Now minus 1 is the only term left. So minus 1. So 2a minus 1 will be in the first bracket. Then we have the next bracket. Now 3a plus a becomes 4a. Because 3a plus a are like terms, so we can add them to give me 4a plus 1. Now, 4a plus 1 cannot be added since they are not like 10. And 2a minus 1 can also not be subtracted because they are not like 10. So I'll leave my final answer as 2a minus 1, 4a plus 1. Don't forget that factorization, most of the questions, the final answers must be in the bracket. So the final answer for 9a squared minus a plus 1 all squared becomes 2a minus 1, 4a plus 1. Factorize 27x squared minus 3y squared. For you to solve a factorization question completely, you need to ask yourself relevant questions like, what type of factorization is involved or will I use in this particular expression? 27 is a coefficient of x squared and minus 3 is a coefficient of y squared. If I check the two coefficients, there is a common factor of 3 because 3 can still divide 27. So I'll factorize 3 out. So 3 out. Meaning, I will first of all use common factors for this question. Factorizing 3 out, we will now use the 3 as a common factor to divide the first term, which is 27x squared. Let me do that one here. It becomes 27x squared as the first term, divided by the common factor 3. Meaning 3 will divide itself 1 and divide 27, 9. 9 multiplies x squared, becoming 9x squared. So this is our answer. Then we take it back to the question, becoming 9x squared. Good. Now let's take the second term, which is minus 3y squared. We will still divide this second term by the common factor, which is 3. So divided by 3. 3 into itself 1, into 3 minus 1. And then multiplying y squared, making it minus y squared. So we have minus y squared as our answer. So let's take it into the question, minus y squared. Now we have finished with the factorization by common factors. If you check the remaining terms in the bracket, we still have 9 as a perfect square, x squared. So there is this part of this question which brings us to difference of two squares. If you can check well, 9 is a square, x is a square, and y is a square with a minus. So difference of two squares will be here. So we need to get it done. Now let's consider that. So 3, then we open the bracket. 9 can be 3 squared and then x squared minus y squared. So gradually we are getting there. Now let's continue. So 3 into bracket, these two can be a single square. So 3x all squared, right? From 3 squared x squared becoming 3x all squared in a single square minus y squared. So clearly we can see the two squares in the bracket. So 3x squared and y squared becomes the two squares with a difference which is minus. So difference of two squares. We proceed to factorize the difference of two squares by bringing two brackets where I have my first square 3x, which is 3x squared, the first square without a square, minus the y without a square. I do the same thing, but this time around I'll add them. So becoming 3x plus y. So this becomes the final answer for the question 27x squared minus 3y squared. This is the final answer. Question 13. The question says factorize 5 minus 20r squared. If you check this question, 5 is not a perfect square, minus 20 is also not a perfect square. So that means that we have to check whether there is a common factor. 5 and 20, there is a common factor of 5. Because 5 can go into itself, that is to say, 5 can divide 5, and 5 can still divide 20. So let's factorize 5 out. We open and close our bracket. Now, this 5 will be divided by the common factor 5. So this is what I'm trying to say. The term 5 divided by the common factor 5. 5 here 1, 5 here 1. So we end up getting 1 as the answer. So we put 1 here. Minus 20r squared divided by 5. So 20r squared divided by 5. 5 here 1. 5 into 20 is 4. So we end up getting 4r squared. Let's replace the 4r squared. So here it's 4r squared. If you check very well, even though it looks like we are done, but within the bracket we have 1 as a perfect square and 4 as a square, r as a square. So there is difference of two squares in the bracket. So let's continue to factorize further. Let's rewrite the terms in the bracket as difference of two squares. So 5 out, 1 squared, 1 is a perfect square, minus 2 squared, r squared. So it is becoming clearer. Now we still have to combine 2 squared and r squared into a single square. So still 5 into bracket, 1 squared minus 2r all squared. We can proceed by drawing 2 brackets, 5 and then 2 brackets. The 5 will still stand against the bracket because it was coming out from the common factor section. Now we add and subtract the 2 squares, or subtract and add the 2 squares. So 1 minus 2r. First square minus second square. Don't bring the squares when you are doing this particular process. Then 1 plus 2r. So subtract the 2 squares and add the 2 squares, but don't forget they will not be squared in this process. Now this becomes the final answer for 5 minus 20 r squared. Thank you very much. Question 14. Factorize mn squared minus m cubed. If you check from this, consider the factorization. M has a common factor here. So we factorize m out as a common factor. Then mn squared divided by m, which is to say mn squared as the first term divided by the common factor m. M goes into itself 1 and still goes here, remaining with n squared. So we will transport or transfer n squared here. Then we have m cubed or minus m cubed. The minus sign is already there, so let me deal with the m cubed. M cubed divided by the common factor, which is m. Now m will cancel itself 1 and cancel the m cubed, m squared. So the answer here will be m squared. Let's transfer it. So m squared. Now, checking from those in the bracket, we realize that we have difference of two squares. So let's factorize the difference of two squares also in the bracket. It will be a further factorization. Let's consider the one in the bracket. So it becomes m, open and close, two different brackets. So n minus m, we consider the squares and subtract them. N minus m, as I always say, don't bring the squares. Do the same thing, but you add, becoming n plus m. So this will become our final answer for mn squared minus m cubed.